Now the next problem is find the area bounded by the curve y is equal to cos x between x is equal to 0 and x is equal to 2 pi. So here we will draw the curve of y is equal to cos x. So the given curve is y is equal to cos x and interval is 0 to 2 pi. So we'll draw the diagram of cos. This is 1 and this is minus 1. This is y dash. So if we see at cos 0, at x is equal to 0, cos is 1 and at pi by 2 it is 0, at pi it is minus 1, at 3 pi by 2 it is 0, at 2 pi it is 1. So we get this is at 2 pi, this is at 3 pi by 2, this is at pi and this is at pi by 2. So we have to find the area of these three regions. So we can see that this is the case when the curve cuts at multiple points. So the required area is area of region OABO plus area of region ACDA. As x is equal to 2 pi is here, x is equal to 0 is here. And the next one is DEFD, that is x is equal to 2 pi. DEFD. So we can see that is modulus I1, modulus I2 plus modulus I3. So modulus I1 is 0 to pi by 2. Sorry, that is I1. We are not writing here modulus. This will be easy to calculate. 0 to pi by 2 cos x dx. That gives integration of cos x is sin x. That is ranging from 0 to pi by 2. So it gives sin pi by 2 minus sin 0. Sin pi by 2 is 1. That is 1 minus 0. That gives 1. Therefore, modulus of I1 is 1. Now we have to calculate the region I. That is pi by 2 to 3 pi by 2. That is cos x dx. So we get here sin x ranging from pi by 2 to 3 pi by 2. So we get sin 3 pi by 2 minus sin pi by 2. So sin 3 by pi by 2 is minus 1 and pi by 2 is 1. So we get that is minus 2. That is the reason I2. So the integral of I3, that is 3 pi by 2 to 2 pi cos x dx. That is integral of cos x is sin x and this is 3 pi by 2 to 2 pi. So we get sin 2 pi upper limit minus sin 3 pi by 2. Sin 2 pi is 0. Sorry, sin 2 pi is 1 Sin 2 pi is 0 and cos 2 pi is 1. Sin 2 pi is 0 because sin n pi is 0. And sin 3 pi by 2 is minus 1. So we get value of I3 is 1. So required area A is modulus I1 plus modulus I2 plus modulus I3. That is, we get 1 plus modulus minus 2 plus 1. That is 1 plus 2 plus 1, that is 4. So required area is 4 square unit. Now the next problem is problem 6. Determine the area of the region enclosed by y is equal to sin x and y is equal to cos x and x is equal to pi by 2 and y-axis. Y-axis means x is equal to 0. So the solution is, we will draw the diagram first of all. This is the x-axis and this is y-axis. So we have to draw the area between y and y is the x is equal to pi by 2. So at x is equal to 0, cos is 1 and at pi by 2, cos is 0. At, say this is 1 of y-axis, and at x is equal to 0, sine is 0, and y at x is equal to pi by 2, sine is 1. So this is y is equal to sine x curve and this is y is equal to cos x curve. So we have to find the region between y-axis and the curve and the y-axis, that is x is equal to pi by 2 and the curve. So the required area is, that is, first let y is equal to f1x is equal to cos x and y is equal to f2x is equal to sin x. First of all, we have to find their intersection point, that is this. So what is this? So to find intersection point, we have y is equal to cos x as well as sin x. So both are equal. So we get tan x is equal to 1. That is, x is equal to pi by 4. So the intersection point is pi by 4, 0. Therefore, required area is mod of I1 plus mod of I2. That is, I1 is 0 to pi by 4, that is f1x minus f2x, and I2 will be f2x minus f1x. So I1x is cos x minus sin x dx and I2 is 0 to pi by 4 sin x minus cos x dx. So now we will find the value. Required area is noted by A. So we will find out the value of I1. I1 is 0 to pi by 4 cos x minus sin x dx. That is, integration of cos x is sin x and sin x is minus cos x. And range is 0 to pi by 4. That is sin x plus cos x, 0 to pi by 4. So by the definition of fundamental principle of integration, we get sin pi by 4 plus cos pi by 4 minus sin 0 plus cos 0. So we get 1 over root 2 plus 1 over root 2 minus 1. That is 2 over root 2 minus 1. That is under root 2 minus 1. So now we have to find the integration I2. that is 0 pi by 4 to pi by 2. So we write here 0 to pi by 4, just correct it, that is pi by 4 to pi by 2, because our reason was this, that is pi by 4 to pi by 2. So make it correct. For I2 it is pi by 4 to pi by 2, and it becomes sin x minus cos x dx. So we will get integration of sin x is minus cos x, and minus cos x is minus remains same, and it is sin x. It is varying from pi by 4 to pi by 2. So minus is taken out, and the upper limit is, and we get cos x plus sin x, that is varying from pi by 4 to pi by 2. So we get I2 is equal to, minus is as out, upper limit cos pi by 2 plus sin pi by 2 minus cos pi by 4 minus plus sin pi by 4. That is, we get cos pi by 2 is 0 and sin pi by 2 is 1, minus cos pi by 4 is 1 by root 2 and sin pi by 4 is 1 by root 2. So we get minus 1 minus 2 over root 2. 2 times of root 2, that is minus 1 plus root 2. So the required area is mod I1 plus mod I2. That is, we get under root 2 minus 1 mod plus under root 2 minus 1 mod. That is under root 2 minus 1 plus under root 2 minus 1. So we get 2 under root 2 minus 2. That is, 2 is common out, under root 2 minus 1 square unit. So it was all about the problem between the curve. Curve may be, you can see here, it may be parabola and line. It is two trigonometric curves. So we can find the area by getting their point of intersection. That is the main step. If we get this, and after getting that, we have to find out which curve is in upper part and which is in the lower part. So we have to cut upper part minus lower part. Then we will get the required area.